All right, we got the number E today. The number E, you should have been exposed to that at least a little bit in Algebra 2. Hopefully remember some of it. If not, it's okay because we're going to go through it anyway. So here we go, the number E. E is an irrational number, kind of like pi, except that the values are obviously different. It is 2.71828, 18284, and it keeps going forever. Never repeats, never terminates. One thing I want you to see before we move on from the slide is it's also on your calculator. If you look right there, right above your button, it says LN, which stands for natural log. There's a little thing, little E up there. Don't use the letter E, which is up here. That's a completely different thing. We're using this one right here. You know, it says E to the X power. That's our E button on the calculator. And again, E is irrational, never repeats, never stops, and it has tons of mathematical uses, as you're going to see. It says find the value of E to the X to 4 decimal places using your calculator. Thank goodness. So the first one says E cubed. Second one says E to negative 2.3. Sorry, gosh, negative 0.23 power. And third is E to the 0, which I know that. Anything to the 0 power is 1, so don't be surprised. And what I did is I went ahead and punched them all in my calculator, took a picture of it down here so that you could see it. And I can't move that. And there it is, E cubed. And they're going to say 4 decimal places a lot. Golly, I'm moving everything. 4 decimal places a lot. And so you have to round it yourself, or I could actually show you how to make your calculator round to 4 decimal places if you're interested in class tomorrow. E to the negative 0.23. The reason that's a fraction is because the exponent's negative. Whenever the exponent's negative, remember it flips it because it's reciprocal. So that's why it became a fraction or a decimal. And then of course E to the 0 power, anything to the 0 power is 1. All right, graph E to the X. I'm going to do like we did yesterday. If I made a table of values, which I'm not going to make too many of them, because it gets kind of big time decimals. But if I plug 0 for X, obviously it's 1, just like yesterday. This is exponential. Remember we talked about yesterday, if a number is bigger than 1, it's exponential growth. Well, 2.7 is definitely bigger than 1. If I went X to the first, if I put 1 in there, I'm going to get 2.7, 1828, all that stuff. So if I go to 1, I'm going to put 2.7, 1828. If I put in a negative 1, it would be the reciprocal of that, which is going to be, way down here. So it's the same kind of curve we saw yesterday. It's exponential growth. It's doing that right there. X-axis is still an asymptote. Domain and range are the same. All that stuff's still the same. Now the second one has a negative x, which means that's the same thing as having this, which means now you have a fraction. So it's exponential decay. It still goes through this point, but these other 2 points are flipped. All right, so that's going to be 2.7 right there. It's going to be down here. It's supposed to be exponential decay is going to go that direction. Okay, so just like we did yesterday, one's growth, one's decay, no big deal. All right, this one says graph each by hand. So that's what the general graph looks like. We're going to shift it around a little bit. This first one says E to the X plus 3 power. Usually I'd have the point right there, but X plus 3 shifts it 3 to the left. So I'm going there. My next point over is going to be up 2.7 in there. The next one's going to be down here. And so my graph's going to look like that. So that's this first one right there in blue. The second one, negative 0.5 X power. So what that's going to do, that's going to shrink it horizontally. But still, if I put a 0 in there for X, it's still going to be 1. So it's still going to cross there. The negative means it's going to be decay instead of growth. And instead of going all the way over to 1 to go up 2.7, it's going to go halfway to 1 because it's been shrunk a little bit. Sorry, it should be over here. I need to erase that last point because I forgot it's decay. That's all I'm going by. It's kind of what we did yesterday. And just moving things around. It's going to look a little bit like that. So a little steeper and like kind of like that. That's not a great one, but it's good enough. Okay, this one right here. First of all, the E is negative, which means it's been reflected across the X. The 1 is positive, so it's been shifted up 1. So technically, my asymptote is right here, is my yellow line for that one. But it's going to be below the line, and it's going to go, it's really growth because E is bigger. So it would be like the blue one has been reflected. So I'm basically going to reflect the blue one down below the X-axis, except the fact that it's not shifted left or right. Okay, so I'm back to here for my point because it's been shifted up. And I'm going to go to 1. It's going to be down about here. The other one's going to be about there. So it's going to actually do this right here. It's been reflected. So the reflection of the blue, but without being shifted left or right, instead been shifted up one. That's a crazy looking graph with lots of colors. Hope that made some sense. Rewatch that slide if you need to. Okay, the last thing today. This is one of its main uses, by the way, of E is interest compounded, except it's compounded continuously. So I guess I should have read the problem. Suppose that $7,500 is invested at 7% interest, compounded continuously. How much will it be worth in 10 years? Now, whenever it says compounded continuously, we're going to use this formula. A lot of people call it the PERT formula because it spells PERT, but it's P with the E to the RT power. So if I want to know what the final amount is, you start with your principal. P was principal yesterday, it's principal again today, times E, which is a number, it's not a variable. The interest rate's 7%, so I'm going to go 0.07, and the time is 10 years. So all you do is you punch that in your calculator exactly like you see it. I'm going to say 7,500. I'm going to go ahead and hit my E, my second E, and it comes up with E, and it's asking you for an exponent. So you can just type in 0.07 times 10 for your exponent, hit enter, and this is what I get right here. In 10 years, it has more than doubled. I get $15,103.15. So quite a bit of growth in 10 years for doing absolutely nothing but, making interest. Pretty good deal. Okay, hope that makes some sense. I hope it's not a review from Algebra 2. We'll work on it like we always do tomorrow, but I hope it's a review. If not, we'll fix it for you and make sure you know it really well. So see you then.